Good morning, students. We are going to see the next, that is isomerism in coordination complexes. Isomers are defined as substances, molecules, or ions with same chemical formulae but having different structures, and the phenomenon is known as isomerism. The differences in structure is usually maintained in solution also. Sometimes chemical formula of the compound may suggest the existence of different isomers, but practically it is not possible to isolate these isomers. It is due to the fact that in such complexes the ligand displacement is very slow. On the other hand, the labile complexes do not show isomerism. This is due to the fact that in such complexes, the ligand undergo a rapid displacement by other ligand. In this section, the various forms of isomerism with coordination number 4 and 6 are outlined for your study. We are going to see the types of isomerism. The different types of isomerism shown by complex compounds are: first one is structural isomerism, and the second is the stereoisomerism. We are going to see their differences. See, structural isomerism, that is first ionization isomerism, second hydrate isomerism, ligand isomerism, linkage isomerism, coordination isomerism, coordination position isomerism, and polymerization isomerism. While in stereoisomerism, there are again two types: geometrical or cis trans or position isomerism, and second one is optical or mirror image isomerism. The first, structural isomerism. This type of isomerism is due to different possible arrangement of atoms or groups in their molecules. They have different ligands within their coordination sphere. In this first type, ionization isomerism, this name is used to describe isomerism that give the different ions in solution. That is, in other words, two coordination compounds which differ in the distribution of ions between those directly coordinated and counter ions present in the crystal lattice are called ionization isomerism. The composition of these isomers is the same. For example, purple or violet colored CONH35Br square bracket complete SO4 is an ionization isomer of the red compound CONH35SO4 square bracket complete Br. These two complexes have the same chemical formula, but in solution they form the different ions. Violet complex ionizes to CONH35Br square bracket complete 2 plus and free SO4 2 minus ions. As SO4 2 minus ions are free, they can precipitated by BaSO4 with BaCl2. On the other hand, red complex ionizes to CONH35 SO4 square bracket complete 1 plus and free Br ions. In this complex, as the Br ions are free, they can precipitated as AgBr with AgNO3. Since SO4 ions in the complex ion is not free, it cannot be precipitated with BaCl2. Examples of ionization isomerisms are CO NH34 Cl2 square bracket complete NO2 and CO NH34 Cl NO2 square bracket complete Cl. Second, PT NH34 Cl2 square bracket complete Br2 and PT NH34 Br2 square bracket complete Cl2. Third, PT NH3 thrice Br square bracket complete NO2 and PT NH3 thrice NO2 square bracket complete Br. Fourth, COEN2 NCS2 square bracket complete Cl and COEN2 NCSCl square bracket complete NCl. See, in this case, in first complex, one ligand is in first coordination sphere, while in its isomer, that ligand is present in the second coordination sphere. Second type, that is hydrate isomerism. This type of isomerism is similar to ionization isomerism. This type of isomerism arises when a different number of water molecules are present inside and outside the coordination sphere. It results from a replacement of coordinated group by water or hydration. For example, there are three isomers of CrCl3 6H2O. See first one, CrH2O6 square bracket complete Cl3. All the three Cl ions are outside the square bracket and are precipitated by AgNO3 as thrice AgCl. Second, CrH2O5 Cl square bracket complete Cl2 H2O. Only two Cl ions are outside the square bracket and are precipitated as twice AgCl. Third, CrH2O4 Cl2 square bracket complete Cl twice H2O. Only one Cl is outside the square bracket and are precipitated by AgNO3 as AgCl. In the first complex, violet color, all the six water molecules are present in the coordination sphere. Other two complexes, water molecules are partly in coordination sphere and partly as water of crystallization. See the examples of this hydrate isomerism. COEN2H2O Cl square bracket complete Cl2 and COEN2 Cl2 square bracket complete Cl H2O. Second, COPY twice H2O twice Cl2 square bracket complete Cl and COPY twice H2O Cl3 square bracket complete H2O. Third, CONH34 H2O Cl2 Cl square bracket complete Cl2 and CONH34 Cl2 square bracket complete Cl H2O. And last, CrEn2 H2O twice square bracket complete Br2 and CrEn2 H2O Br square bracket complete Br H2O. Here, in first isomer, water molecule acts as a ligand, while in its isomer, water molecule acts as a water of crystallization. Third type, ligand isomerism. This type of isomer contains, that is, ligand themselves exist in isomeric form. For example, diaminopropane can exist as 1,2-diaminopropane represented as PN and 1,3-diaminopropane known as trimethyldiamine TN. See, propane, then 1,3-diaminopropane, 1,2-diaminopropane. The ligand PN and TN, when associated into the complexes, the corresponding complexes are isomers of each other, and hence COPN twice Cl2 1 plus and COTN Cl2 1 plus are ligand isomers of each other. The ligand 1,2-diaminopropane and 1,3-diaminopropane, when associated into complexes, the corresponding complexes are represented here. See, they are the isomers of each other. Other examples of ligand isomerism is COCl En twice NH2C6H4 Me square bracket complete Cl2, and in this complex the ligand NH2C6H4 Me toluidine may be in ortho, meta or para position, that is they are isomers of each other, and hence the complexes of these ligand are isomers of each other. Fourth, linkage isomerism. See, in this type of isomerism, when monodentate ligand has two different atoms are available for the coordination, the linkage between metal and ligand in one isomer is through another atom, and in its isomer it is through other atom. The best known ligand of this type are NO2 SCN minus S2O3 twice minus ions. For example, nitrate ion NO2 in cobalt third complex can be attached either through nitrogen as CONO2 or through oxygen as COONO. NO2 it is nitro and ONO it is nitrito. See, in square bracket NH35CO NO2 square bracket complete Cl2 and NH35CO ONO square bracket complete Cl2. Here only difference of NO2 ligand attached to the metal atom cobalt. In first complex it is attached through nitrogen and in second it is attached through oxygen. Thus these two complexes are the isomers of each other. There is difference in attachment, that is linkage between the metal and the ligand, and so such type of the isomerisms are called as linkage isomerism. Other examples of this linkage isomerisms are NH3 twice Py CO ONO twice square bracket complete NO3 and NH3 twice Py twice CO NO2 square bracket complete NO3. Second, NH3 IR NO2 square bracket complete CO2 and NH3 IR ONO square bracket complete Cl2. In this complex, all ligands other than NO2 are written to the left of the metal in order to trace how the nitro ions is bound to the metal. Otherwise, generally in square bracket we write the metal first and then ligand. Here sequence is changed only for our understanding. Other examples, see CrH2O5 SCN twice and CrH2O5 NCS square bracket complete 2 plus. See the name of these complexes, that is another examples of this type of the linkage isomerism and their names. NH4 square bracket complete Cr NH3 twice NCS4 square bracket complete ammonium tetraisothiocyaneto diamine chromate third, and its isomer is NH4 square bracket complete Cr NH3 twice SCN4 square bracket complete. Here there is the attachment through the sulfur. See its name ammonium tetrathiocyanato diamine chromate third. See another example, NH4 twice in square bracket PtSCN6 ammonium hexathiocyanato platinate fourth and NH4 twice in square bracket PtNCS6 square bracket complete ammonium hexa isothiocyanato platinate fourth. Another example, Na3 in square bracket AgS2O3 square bracket complete sodium bis S thiosulfato argentate first and its isomer Na3 in square bracket AgOSO2 S twice square bracket complete sodium bis thiosulfato dash O argentate first, that is in first complex S2O3 joined to metal atom through sulfur atom and in second it is joined through the oxygen atom. Thus there is a difference in the linkage and thus all these are the examples of linkage isomerism. Fifth type, coordination isomerism. This type of isomerism shows the position of both cation and anions in the complex. It will get changed. Coordination isomerism is due to the interchange of ligands between complex cation and complex anion. For example, CONH36 CrCN6 and CrNH36 COCN6. Here the ligands will get exchanged and we can get the different complexes. There is the in first ion the cation have the NH3 ligands and anion having the Cn minus ligands, but they will get exchanged with the metal ions and we have the corresponding isomer. Another examples, CONH36 Cr C2O4 thrice and CrNH36 CO C2O4 thrice. Next, Cu NH34 2 plus PtCl4 2 minus and PtNH34 2 plus CuCl4 2 minus. The same atom may be coordination center in both cation and anion. CrNH36 CrSCN6 and CrNH34 SCN2 CrNH32 SCN4. Thus there is a change in the position of the ligands and it is called as the coordination isomerism. Coordination position isomerism. This is a special type of coordination isomerism. It is shown by bridged complexes. It involves the different placement of ligands. Place of the ligand is replaced. See, NH34CO 2OH bridged ligands CO NH3 twice Cl2 square bracket complete SO4 and Cl NH3 thrice CO 2OH bridged ligands CO NH3 thrice Cl square bracket complete SO4. See, if the first complex is unsymmetrical, Cl ligands at one side, but in second one of the Cl is replaced with the NH3 and we have the symmetrical composition of the ligand. There is the position of the ligand will be get changed and so it is called as the coordination position isomerism. Last type of structural isomerism is polymerization isomerism. This isomerism occurs in compounds having the same empirical formula but different molecular weights. The molecular compositions are multiples of the simplest stoichiometric arrangement. For example, CO NH3 thrice, NO2 thrice, square bracket complete twice, and CO NH36, CO NO26, and second example PT NH3 twice Cl2 square bracket complete and PT NH34 PtCl4. See the first isomer and second isomer, they having the higher weight and thus we having the isomers of that particularly complexes.